2b. The number 6 has exactly 4 unique factors, 1, 2, 3, and 6. How many counting numbers less than 20 have an odd number of unique factors? So this is saying that, this is giving an example. The number 6 has this much factors, 1, 2, 3, and 6. They're all unique, which means that it can't be, you can't repeat it. So it has 4 unique factors. So how many numbers less than 20 have an odd number of unique factors? Well, if you think about this, all numbers that are all numbers that have an odd number has to be all numbers that have an odd number of unique factors cannot be prime, because prime numbers only have 2 factors, one in itself, and that is not an odd number of unique factors. Okay, so it cannot be a prime number. So if it's not a prime number, then it's got to have an even number of factors, right? I mean, each factor pairs with itself, so it must be even. You're right, but not fully. Because you remember, it's unique factors. Unique factors means that if, say for 9, it's 3, it can be 3 times 3. So for 9, it can be, for 9, it's going to be 1, 3, 9. And the reason why I didn't write a second 3 is because it has to be unique factors. So 3 only comes once. So the factors of 9 is 1, 3, and 9. Okay. So that's going to be one example. Of course, it has an odd number of unique factors. But are you starting to see a pattern here? In only what condition is only one factor omitted? The condition is that if that number is a perfect square. This makes sense because perfect squares factors are all the number that squares equals it and 1 in itself. So for 9 would be 1 and 9, it's 1 and 9 itself. Then 3, it's 3 times 3 is equal to 9. So all perfect squares have this pattern because one number is always omitted. That means that they have an odd number of unique factors. Now, which of the perfect squares are less than 20? There's 1, there's 4, there's 9, and there's 16. The next one, 25, is over 20, so that would not count. So the answer is 4 numbers. 4 numbers less than 20 have an odd number of unique factors.